Good afternoon, everybody. Thank you for joining us. I hope you've been finding the Passivhaus workshop helpful so far today. My name's Katie and I'm the course coordinator at the National Self-Build and Renovation Centre, and I will be facilitating Clarissa's session today. I'd like to welcome you to the 2 p.m. presentation, Why is efficient heat recovery and ventilation key to good indoor air quality and energy savings in a passive house? This will be presented by Clarissa Uden, and she's from Total Home Environment. If you want to ask Clarissa a question at any point, please send them through to the question and answer function below, and we will have time for a few questions at the end. Following this session, we've also got our question time at 3 o'clock. Like the previous sessions, this one will be recorded, and we're going to send out the links for you to access these recordings after the workshop. So without further ado, I will hand over to Clarissa. So Clarissa, if you'd like to turn your camera on. Oh yeah, brilliant. I will hand over to you. Thanks very much.
Thank you. Good afternoon, everybody. I hope you're all well. As a company, Total Home Environment does heat recovery ventilation, air source heat pumps, air to water heat pumps, compact surface units, everything to get your home as sustainable as possible and as healthy as possible. We also do NCS certification, room by room heat loss calculations, and SAP Appendix Q reports. Today, I am just going to be talking about heat recovery ventilation and why it is good to have it in a passive house home, especially. So without further ado, I hope you're all sitting comfortably. I'll begin. So obviously, in the olden days, people didn't really take much care on how they built their houses, and a lot of cold air would come in, and any heat that you would generate inside would just go up the chimney. Obviously today, these days, and especially with you lot who are thinking about passive house certification, all the heat is kept in and all the cold air is kept out. However, this good air tightness and good insulation does have a side effect, and that's what I would call the cling film effect. And unfortunately, even as far back as 2009, the NHBC identified a link between indoor air quality and the health and all of those residential respiratory diseases you can see on screen. And of course, in more recent months, obviously with coronavirus, air quality is a consideration that is high up on the list. Most of it in a domestic property is caused by materials that you naturally put in with your house: carpets, curtains, laminates, paint, detergents. And don't even get me started on room sprays that people on purpose squirt and even plug in and have spouting out chemicals every 20 minutes or so. Then you've also got radon gas. Now, this isn't going to be such an issue if you're doing a new build, but if you're doing a renovation, this is a gas that you can't see, you can't smell, and it's the second biggest cause of lung cancer in the UK. Now, on that very tiny map there, hopefully you can see my mouse moving around, the dark brown patches, about 30% of homes will be at risk of radon gas, and the white areas, about 1%. If it's a new build, as I say, you'll probably already have a vapor barrier built into it, but it is certainly something to consider if you're not going to be digging up floors and things. Then you've got mold and mildew. These spores are dangerous in the air and tend to come about when you've got moisture up against a cold surface. And this is really, really bad for asthma and allergy sufferers. Then you've got carbon dioxide. This is the air that you breathe out of your mouth. And in a typical bedroom, for instance, with 2 people sleeping in it, within just 1 hour, you are starting to rebreathe the air that's already come out of your mouth. And it's not pure. And this is why even after, say, 8 hours sleep, you feel, when you wake up, you still feel tired, your eyes are itchy, maybe you're a bit bunged up, you've got a headache. It's because of the fact that you been breathing more carbon dioxide than oxygen. Now, typically, outside, the parts per million of carbon dioxide would be about maybe 300 or 400 parts per million. Now, that can build up inside a house, and what is considered an actionable level is 1,000 parts per million. You can see on this graph here, this is a study done over the winter period back in 2012, over a couple of days. You can see that the carbon dioxide level, this navy blue line, is getting up to 5,000 parts per million. That's 5 times more than this actionable level at the turquoise line. And this is dangerous. This is really dangerous for people at either end of the age spectrum and for anybody who's in a vulnerable state with any respiratory problems. And of course, with Passivhaus, all of this is magnified because they don't want an air change of more than 0.6 with regards to air tightness. And so with Passivhaus, they say, right, okay, let's get some controlled ventilation between 20 and 30 meters cubed per person per hour. So we've got enough fresh air coming in. But they also want thermal comfort. So, you know, you really can't have windows open because you're going to be letting a lot of cold air in. And with regards to overheating, which I'm sure Anne mentioned earlier on, you don't want more than 10% of the time above 25 degrees. And of course, this picture says 1,000 words. It's not the solution. You're letting cold air in, all that hard-earned heat go out. You're letting mosquitoes in, flies, air pollution, whatever it happens to be. And of course, it's a security risk. And to actually get adequate ventilation through opening a window, you'd actually have to do that every 2 hours for at least 10 minutes each time. And that's frankly quite inconvenient. So this is where heat recovery ventilation comes in. So I will try and briefly go through this. I hope nobody is already too compos mentis with regards to this, but basically here we're showing the unit in the loft area, and the unit, the ventilation unit, has got 2 fans in it. One fan draws fresh air from outside, whilst the other fan gets stale air from kitchens and bathrooms. The 2 airflows cross each other, but they don't mix. The stale air gets chucked out, minus its heat. The fresh air that's now been nicely warmed then gets put via ducting and ceiling terminals through to the habitable rooms of your house, like bedrooms, living rooms, dining rooms, that sort of thing. And it means you get a whole house air change every couple of hours, and you're recycling 95% of the heat that you'd otherwise lose through trickle vents and extractor fans. So you can see how people say, oh, I've been able to reduce my heating bills by 1/3 just through having heat recovery ventilation. So if we look at how this works with regards to temperature, if the air outside is 0 and it's 21 degrees inside the house, you can expect to recover enough heat from this stale air to put this fresh air into your supply rooms at 17 degrees, which means that any heating system that you've got has only got to find that 4 degrees difference. Whereas with any other form of ventilation, opening a window, trickle vents, etc., it's whatever the temperature outside is that your heating system has got to cope with. Now you can go a step further, and this is where heat pump ventilation comes in. It's the same sort of format. You've got the unit, it's got 2 fans in it, and it's bringing fresh air in, taking the stale air out. But in addition to the heat recovery matrix, it's also got a little micro air source heat pump inside it to add just a little bit more heat to the air that's going into your supply rooms. You can see here we've got a couple more different temperatures going on. It means that perhaps upstairs it could be a different temperature where you don't necessarily want to be as warm because you're under a duvet. And then downstairs when you're in the living room watching TV, you want it to be slightly warmer. The beauty of this system is that it can be reversed to provide cooling too, which is great for those summer months. Now, obviously not all rooms are the same, even if they are built with the same fabric. And you will find certain rooms that have, say, got maybe 3 external walls rather than 2 are always going to be colder than the rest of the house. Now here, with this system, you can also control separate little either heated ceiling terminals that you would slot in instead of a normal ceiling terminal, or perhaps a radiant panel, which means that you can have specific room temperature control as well in those supply rooms that actually need extra heating. Also here, you'll notice that we've got what looks like a water cylinder. Well, this is called the HPW. This is basically a 300-litre cylinder with a micro heat pump on top of it. And that does all your domestic hot water, the hot water coming out your taps. And also, if you've want a little bit of underfloor heating, perhaps in an ensuite bathroom or something like that, it can be the feeder for that and the energy source. So you can see how this whole system can be everything that you need, whilst using the infrastructure, mostly of your ventilation that you would have in any sort of passive house situation. So with regards to the HPV and going back to temperatures again, same scenario of 21 degrees and in the house and 0 outside. Here you've got your bedroom supply, which comes off before the heat pump gets involved. This is the heat pump here on the left and the right. And then you've got the potential of supplying much more higher temperatures to the supply rooms of the house. Now, typically that will probably be about 30, but you can see that that would be a maximum there. And you've got more controllability on temperatures. And with cooling, those temperatures, again, we've obviously changed it to be a bit like the summer, so 30 degrees outside and perhaps 26 being extracted from the house itself. And with that amazing energy efficient refrigeration cycle, you've reversed the heat pump, and instead of providing heat, it's providing cooling, and we can perhaps supply the air in bedrooms and living rooms at between 10 and 15 degrees. Now, don't get me wrong, this isn't like air conditioning. You're not going to get 20 or 30 degrees difference in temperature, but you will get maybe 5 to 10, which can be the difference between a good night's sleep or not. So you can see the potential here for comfort and keeping those temperatures within the house below that 10% that I spoke about earlier. The system's very energy efficient, and in this, if you've got a Passive House certified unit, it will have an automatic summer bypass, which will come into effect in the summer months when you don't actually want to recover heat. You just want that lovely fresh filtered air coming in. And you can see here that the controller is set to 22 as an ideal temperature. The hysteresis is at 25, which means basically you don't want the machine turning off and on every time it goes to 23 degrees. So it doesn't actually start to react until its sensor says 25. So here you can see automatic summer bypass coming down, the airflow being extracted out of kitchens and bathrooms. It doesn't go through the heat recovery matrix. It goes past the heat pump. Fresh air is drawn from outside and goes through the cold side of the heat pump. And hey presto, all very energy efficient cooling going on here, with the automatic summer bypass doing the work first. So with regards to heat losses, typically in probably a passive house type house, your total heat loss could be about 4.8 kilowatts, with almost half or more than half in this case associated with the ventilation side of it rather than fabric side of it. So it is quite a serious loss that we're talking about just to get fresh air into your home. So if you put a heat recovery ventilation unit into the mix, you're severely reducing that heat loss. And if you put heat pump ventilation, instead of a loss, you're actually getting a 60% gain. So you can see how effective this technology is in helping create a lovely home environment. So briefly going over the main benefits of heat recovery, it's lovely fresh filtered air, getting rid of all those nasty chemicals and humidity, so dust mites won't be so prevalent. So, you know, another plus point for allergy sufferers. Again, you won't have to worry about redecorating over mold and mildew stains and wiping that mirror down after a shower. All that moisture is going to be removed. Obviously, with the whole house air change, you're going to be getting rid of odors all the time and recycling 95% of the heat that you would normally lose. Obviously, you're going to get cost savings, especially over winter. If the system is designed and installed correctly, then you should never, ever hear it. And conversely, you won't have to be opening windows, so you're not going to get any noise coming from outside. And of course, this makes your whole house more secure as well, if you're not having to forget to close windows and things like that. Obviously, if it's Passivhaus certified, that is your guarantee of quality, and it should more than cover building regulations. If you have heat pump ventilation as well, you're going to get very energy efficient space heating. Now a COP of between 3 and 12 is really good. Just to explain, a COP is how much energy you put into something, how much energy you get out. So it's a coefficient of performance. Now with a gas boiler, you're putting a kilowatt of energy in, you're only going to be getting 900 watts out. So you'd be saying, well, where's my 100 watts? Thank you very much. So with 1 kilowatt of energy, you're getting at least 3, if not 12. Now, obviously the 12 is going to be ideal scenarios, but typically with this sort of system, it will be 5 or 6. So really good energy efficiency there, much, much better than coal, etc. Because you're using the ducting from the ventilation system, you're not going to have any other infrastructure that you're going to have to add. So you're not going to have any underfloor heating that has to be put into the floor. So, you know, installation times are all a bit quicker. And obviously, if you're off gas, this sort of system, along with air source heat pumps, of course, is ideal for off gas properties. With that, possibility of those cold rooms needing perhaps radiant heater or the heated ceiling terminal, you've got much more precise and controlled delivery of heat. Lovely though underfloor heating is, it can take a long time to respond to changes in temperature. Obviously, you've got that energy efficient cooling with COPs of about 4 or 5. You've got 1,000 litres of water a day. Again, all heated up energy efficiently. The water tank has probably got a secondary coil, so it can either feed a little bit of underfloor heating or accept some heat from solar thermal panels if needs be. And there is a controller app for remote control or diagnostics. So how can you tell whether the heat pump ventilation type of ventilation system is the one for you? Well, here you can see a matrix that on the left here, you've got your house size in square meters, and then along the top, that's how many watts per square meter of heat loss you're getting. Now, Passivhaus standard equivalent or certified, you can see here, these are the whole house heat losses we're expecting. So a typical house, maybe at 175 square meters, you're going to be getting these sort of heat losses, doing really, really well with your air tightness and your insulation. At this point, you're not getting a lot of airflow, so we wouldn't recommend it, just plain heat recovery ventilation. Obviously, you don't need any heating with only that sort of heat loss. So how do you figure out what your heat loss is? Well, you've got the PHPP, which will go some way to figuring out what's going to be appropriate. But you've also got the option of getting a room by room heat loss calculation completed. And here you can see we've got a postcode top right, which tells us what sort of temperature, average temperatures you've got in where you're going to be building or renovating. You've got all your U values for the walls, the windows, the doors, floors, etc. And your air tightness, what your expected air tightness figure to be. And down here on the left, we've got each room and what its area and volumes and airflows need to be. And then here we're getting down to the nitty gritty of the heat losses. And here we've got a figure of 5 kilowatt heat loss for the whole house. However, that's not the figure that we're going to be looking at, because you need to be able to have your house warm from a standing start, from when nobody's been in there for 3 months. So here, that's been added, and the whole house heat loss for this particular building is 6 kilowatts. We then see that with, I'm not sure if you can see it on your screens, but this is when you add heat recovery or heat pump ventilation to the mix, and we've managed to reduce it down to 4.2 kilowatt heat loss. Then we do expect that you will have some ancillary heating, like towel radiators in bathrooms or a wood burning stove or something like that. And we're reducing down and down until we've only got a 300 watt heat loss, which we've covered, as you can see here, with 2 heated ceiling terminals. So at this point you go, no, I don't need to go for a formal heating system. Heat pump ventilation is for me. Obviously, if this was in red, then you'd know that actually, yeah, need to go down the air source heat pump route with underfloor heating, etc. So this can be used in any sort of circumstance to make sure that you're getting exactly the right ventilation and heating solution for your home. So getting back to the ventilation unit, things to expect a bit more on a practical side here. Units can be ceiling mounted. Mostly they'll be on the floor, either vertical, so a bit sort of next to maybe kitchen unit type situation, or you can mount them on a wall and still utilize the area below it. Key components to look out for, especially on those specification sheets, is low power fans, EC motors, electronically computated. Also having really high quality filters, F7 pollen filters, especially for those who have allergies or asthma, or if you're near arable land and stuff like that, they're very, very useful. If it's Passivhaus certified, then it will definitely have a heat recovery rate of over 75%. And do make sure that the unit itself is well insulated with at least 30 mil of insulation inside it to keep it at its own temperature. Obviously, Passivhaus certified, it should have an automatic summer bypass. You really don't want to be putting in a summer block every time the weather changes, especially with the UK, which is up and down like a yo-yo all the time. Make sure it's Passivhaus certified. As I say, that's your seal of approval. And if it is, then it should also be SAP Appendix Q ready as well. Obviously, if you are into the idea of having one infrastructure for heating as well, make sure you get one with a heat pump in it for some space heating and cooling. And don't forget to look at the controllability. It's no good having a whiz of a unit if you've only got an on-off button and a boost switch. You know, control is everything when it comes to efficiency. And here on this particular controller, you can have your target temperature, you can have loads of information about what the weather's doing inside as well as out, and what your airflows are. Here, this is probably the most important thing, being able to be told when your filter needs to be checked, because if your unit is having to suck through a filter that is like a wall of dirt, it's going to be working harder, you're going to be using up more energy, and there's going to be more wear and tear. So that is absolutely paramount to know, be able to be told when a filter needs to be checked. Here you've got a main menu where on commissioning, exact increments, percentage increments will be sorted out for all the airflows and the target temperatures, etc. Here, knowing what your fan speed is, because you don't want the system on at the same level all day. At night it will be on 25%, the day 50% say, perhaps it will boost up to 75 during showers and cooking and stuff like that. And then you should always have the option to manually press on a boost as well. Say if you're going to have a party and you want to have it on for maybe 2 or 3 hours extra, being able to control that and then not have to remember to turn it back down again afterwards is very convenient. If you've got the units that have got extra heating or perhaps an inline duct heater or something like that, that is where you will control that. So you can see this all makes the system much more efficient and much more convenient for you too. So thinking about where the units are going to be placed, it's not just the units that you have to think about. Don't just look at the specification sheet and think that's it. You are going to have bends off the units, you're going to have silencers. If you're going to have any connections to underfloor heating from your water heat pump, then there needs to be space for that. The ventilation unit is going to be creating condensation. It's collecting moisture in the air, so that needs to be removed from the unit. So a plumber will need to get involved in plumbing that up to the house plumbing system. Filter maintenance, are you going to be able to physically pull out the filters in front of the unit? Because you need to check those every quarter or every 6 months. Insulation, there will be insulation around the ductwork as well. Is the location going to be in a room, a place where it's still within the thermal envelope? And then electricity wise, both units will need electricity, and if you're going to have heated ceiling terminals or radiant heating panels, then they need control cables, they need electricity to get to them too. So there'll be a PTC module which will do all the controlling of the electrics and the humidistats and things like that. So really, please, 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 see the please on my face here, get a plant room designed into your home. It's really the best place to put all your services. It's all in one place, all easy to get to and maintain. Failing that, then perhaps a utility room. You've still got that space underneath to be able to put washing machines and etc. If you have to have it in a cupboard, obviously note the fact that you've got to pull those filters out, that you've got those ductworks coming out, etc. So don't just look at the specification sheet. You do need a good 2 to 3 meters to put this tech in. You might be able to use your attic, but obviously you need to be able to get to it, especially if in a loft. If you've got a rickety old loft ladder, you need to have good transport links to it to be able to check those filters. And here you can see some pictures of the units in situ. We've got some loft ones here on the left, attic, that's some sort of outhouse, I think. Here we've just got it in a hallway. That's a cupboard down there on the left. We've got this is the utility of the Build It House, education house in Gravenhill and Bicester. That's in the utility stroke plant room. And here we've actually got some in rooms. I think there's a bathroom, and that's sort of a conservatory type situation. So you can gather the sort of size we're talking about. So the next thing to think about is ducting. As a company, we would always specify rigid metal safe seal ducting. It's naturally antibacterial, nobody can crush it, no mice can eat through it, airflows on paper actually happen in practice, and especially when you're thinking about some of units we've got the heat pump in, there's absolutely no off-gassing potential there. Another type is radial ducting. This is a smaller bore, so you may need more than one pipe going into each room, depending on the size. Also, you do need distribution boxes, one for the supply side, one from the extract side. So you need to think about where they might be able to go, because they are about half the size of the unit again. And then obviously the insulation you need if it's in a cold roof. And we wouldn't specify this if it was with the heat pump ventilation because of the off-gassing potential. And if your quote is too good to be true, make sure that it's not flexible or semi-rigid metal duct, because they wouldn't pass SAP Appendix Q either. So where is the ductwork going to go? Well, in traditional floors, that's where mostly, well, in a house, most of the ductwork does get lost in the floor area. But in traditional floors, if you're doing a renovation, you can only work with the joist. You can't cut across them. So you have to be slightly clever on where we would hide the ductwork to get it across to other areas of the house. Beam and block, great, but just make sure that the void depth is enough to take the 90-degree bend that comes off to the ceiling terminals. But the ductwork can go anywhere in there. Webbed or posi joists, good. One with, go across. Just make sure that all the W's actually line up, so that you don't have to cantilever the ductworks, otherwise it's a pointless exercise. And I-beams or engineered beams, these are good. You can run across them, but you do need to check with your engineer exactly how big the holes can be and exactly where in the beams they are allowed to be. Then you've got the terminals. You'll have one in each room. It will normally either be a supply or an extract. Sometimes, occasionally, like a conservatory or big open plan area, you will have both in that area. They're normally opposite a door and mostly in the ceiling. Sometimes you would have to have them in a wall if you've got a vaulted ceiling, because, for instance, a supply, if it was above 2.4 meters in height, you wouldn't actually feel the benefit of the heat, the air and the heat that would be coming out of it. And conversely, if it's an extract, you really want it to be within 400 mil of the ceiling itself to actually get that stale warm air out. Controllers and sensors and things like that, the main controller would always be in a common area away from sun or heat source, because obviously it's got sensors in it. And then if you have any individual heated ceiling terminals or radiant panels, then you would have a room controller as well. And of course there would be the carbon dioxide stroke humidity sensor, perhaps in bathrooms and living rooms. And you've got the mobile app as well. Breakout points where your fresh air in and stale air are going to be coming out. Normally these are in end elevations or soffit walls or the roof. just have to watch house orientation, because we don't want to be getting the fresh air in from the south side, and if there's any prevailing winds, that could cause some whistling to go through the house. And you certainly wouldn't put an extract on one side and fresh air on one side and the exhaust on another, because you'll get different pressures going on. Best practice, you would keep them at least 3 meters apart horizontally, or 1 meter vertically, and do keep them away from soil vent pipes. You don't want to be getting fresh air in from there. Domestic hot water, we've been talking about the heat pump, the HPW, that has 300 litre cylinder, good for a family of 4. It does about 1,000 litres a day. It automatically has an anti-Legionella cycle running, and as you know, it could feed a little bit of underfloor heating, or it can accept solar thermal, and it can all be controlled by the HPB's series controller as well. So information that we, for instance, would need to establish what ventilation system is going to be best for you is what your build method's going to be to get this room by room heat mass calculation done and a quote done. And we'd want to know your U values for wall, floor, roof, windows, doors, etc. And buildings regs drawings would be very useful, rather than just something slightly earlier. We need sections to work out the volumes. We'd like to know if you've got an air tightness champion on site, what sort of air tightness target you're going to get to, obviously your postcode, and any sort of towel radiators and things like that that you might be having. Once you place an order, you should get 3D CAD design done, which gives exact ducting specification, where insulation, where the duct's having to run through, it's a cold space, etc. It needs more insulation. This really does reduce on-site installation time, and it helps other trades keep out of the way of these ducts. These ducts are quite large, they're quite big, and they're not very flexible in where they can go in comparison to the tiny bore copper pipe that for instance, your plumber will be putting in. It's useful to have drainage plans at this point, because then we don't even argue with drain pipes and soil pipes, etc. And it helps, obviously, with the plumber being able to know that where to put the condensate in. Other places that duct will flow will be boxed in with soil vent pipes, or at the back of fitted wardrobes, airing cupboards, stud walls, that sort of thing. So you'll see that on the design too. Now, this probably is going to be the biggest system that you're going to put into your home, so you really do need to plan for it. Do talk to us early and have all that information. Please do design that plant room in. Get that room by room heat loss calculation done, so you know exactly what sort of system is going to be relevant for you, and whether it's just plain heat recovery will be enough, or whether you do need something meatier down the air source heat pump line, or the heat pump ventilation unit will do everything for you. Budget-wise, materials for heat recovery ventilation, anything between £2,500 and £7,000 is probably good. And then for the heat pump ventilation, it's doing all that heating and cooling hot water as well, so that is more expensive. Anything between 14 and 30,000 odd. You've also got to figure out whether this is something you think you can do yourself. We would always do the commissioning side of it if you did the installation yourself, or you could pay a company like us to professionally install it for you. Installation timings, typically for heat recovery, you're looking at about a week for the first fix and a couple of days for the second fix. And if it's the heat pump ventilation, because it's a bit more involved, you're looking up to anything about 3 weeks for the first fix and about a week for the second fix. And then anything between 1 and 3 days for commissioning, depending on how complicated the system is. Please do talk to your other trades early as well. I mean, prepare your electrician that doesn't have to quote you for extractor fans, etc. But he does need to quote for getting those fuse spurs to where the units are, and where any electrical, the control cables and things like that. Make sure your plumber is aware of connecting up that condensate and connecting up to the air to water heat pump. It is all pre-plumbed, that particular unit, but there is obviously still some connection to do. Tell your window manufacturers they don't need to quote you for those trickle vents, which should actually reduce your window quotes if you've already got them. And do tell your joiner when he's putting the doors on that there needs to be a 10 mil gap between the bottom of the door and the finished floor level, the carpet or hard floor, whatever is going to be there. Otherwise, you're going to have to put a vent in the door because you do need to have a nice through flow of air there. I think that's probably it now. We do have, obviously you're not going to be able to go now across to our stand at the Self-Build Centre, but obviously hopefully in the future you'll be able to visit there, or if the Passivhaus in St Neots has got one of our ventilation systems in it. We've got a showroom and training facilities in Morton in Marsh, and there is the Build It education house over at Graven Hill in Bicester that also has the HPV unit in there and the HPW working. So I think that's probably it for me. If there's any questions, I'm sure Katie's going to come up with them. Thank you.
Yes, thanks, Clarissa. We've had a few questions come through. So the first one that I'll ask you is from Duncan. And Duncan has asked, can a ground-to-air heat exchanger before the MVHR negate overheating in summer and drastically decrease heating required in winter?
Right, well, if Duncan was here, I'd be asking him if he was thinking about turning his underfloor heating into cold, which I would never, ever, ever recommend because you'd have condensation issues. If he's thinking, it's a bit of a complicated question, that, and I need to ask him a few more questions really to get specifically down to it. But yes, if he was going to use his underfloor heating ducts to cool the air, then, I mean, to cool the floor, absolutely not. I wouldn't go down that route. If he was thinking about how you could get duct from underground, so extract the air from outside, take it underground, then yes, that would have a cooling capability. That duct is quite expensive. So if money is nothing, then yes, it would possibly be worth doing, but it would be a balance there.
Okay, thank you. The next question is from Grant, and it's, would you ever supply the air into rooms via the floor outlets? Although I think you might have covered that possibly in the last question.
Can do if you're absolutely desperate. Personally, I don't like the idea of air being introduced into the room at floor level because I worry about how dirty they're going to get. And if things could get stuck in there and dust and whatnot, which obviously settles down. I mean, you don't get, I mean, this is one of the plus points of ventilation systems. You don't get as much dust in the house. I mean, I certainly don't dust as much as I used to before I had a ventilation system, because of course you're changing the air in the house every couple of hours or so. So it's naturally drawing dirty air out. So for me, if it's a last resort, I would say yes at floor level.
Okay. Next question is from Jay, and Jay has asked, when used in an efficient passive house, can these ventilation systems with the micro heat pump be the main source of heating and cooling, or is it a supplementary source?
No, as I say, it's you can utilize the infrastructure of the ventilation system, but you do really have to, and I'm sure I'm repeating myself, you really do have to have an air tightness champion on site. All the people on site have to be on side. They have to understand that, you know, insulation put in like this, with this gap, is not good enough. It has to be like that. Otherwise, you might as well have not had the insulation, the whole slab of insulation in the first place. I mean, a lot of houses at the moment, you know, they look great on paper, but if it doesn't actually happen in practice, you could probably have a hole this sort of size, you know, sort of cash machine size in the house. That would be all the gaps that people would have in their houses, just because people can't be bothered to have the attention to detail. So as long as what happens on paper happens in practice, this could be everything. But you just have to get your U values really, really low and your heat losses low, and then this can do everything. And we've got a lot of people over the years, for 20 years we've been running, we've had heat pump style ventilation units, and they love them. Some people sometimes think, oh, resale, I must put some heating in, we can't sell it, people won't understand that the house doesn't need heating, and they put it in and they never use their little bit of underfloor heating, and they wish they hadn't spent the money on an air source heat pump or whatever. So yes, you know, that was a short answer, wasn't it?
We've probably got time for a couple more. So Anthony has asked, can your heat pump hot water tank take a feed from a solar panel as well as heat a bathroom radiator, or is it just one or the other?
It's just one or the other, because it's one secondary coil that I can either accept heat or supply heat. So yes, it would, I mean, you could always, obviously it can accept free electricity from your photovoltaic panels. But yes, no, the element is just one way.
Okay. So Christopher's asked what the typical life of an MVHR and associated equipment would be.
Well, there's a question. Well, a heat recovery ventilation unit hasn't got a lot of moving parts, and I think we've got clients who've had systems for 30 odd years, still going strong. I mean, occasionally they have to have a service and stuff, but there's not a great deal to do. And even the ones which have got a heat pump in it, a heat pump is just like a fridge. How many times do you replace your fridge unless you want to get one of these American style ones or these beautiful retro 50s ones? You don't tend to replace them, and it is just a refrigeration circuit. So hopefully, you know, that gives you an idea that they just last forever, basically.
Okay, I'll just ask one more then, Clarissa. So Stephen's asked, what are the running costs and annual service, running costs, brackets, annual servicing, filters, etc.?
Okay, running costs for heat recovery ventilation, it's probably about 150 quid a year, because the fans are really small. They don't take up much electricity. It's like running a couple of light bulbs, or the old-fashioned light bulbs, I should say. Heat pump ventilation, possibly £300–400. It really does depend on how much heat you need, because obviously if you can insulate your house more, you don't need as much heat, etc. Filters, it really does depend on where you live. If you're next to a busy road, or you've got arable land outside your garden with lots more dust, etc. coming up, then your filters will need cleaning more. You'll be looking at perhaps, I mean, your unit will tell you all this, but you'll probably be reminded maybe every 2 or 3 months to check it in those sort of areas, whereas it could be 6 months in other areas. And perhaps you might change them after you've cleaned them a couple of times. You know, when they start to look like, nah, I don't want to breathe the air through that, then you'd buy some new ones, and that's probably once every year, once every couple of years. It really does depend on where you are in the country.
Perfect. Thank you very much for that, Clarissa. It was a great presentation.
Pleasure.
Thank you very much to everyone who's joined this session. Again, you'll receive an email containing the link to watch this webinar back if you'd like to. So next, we've got our final session, and it's going to be the question time session, and that's from 3 until 4. It will be hosted by Chris Herring, and it's going to be joined by all the presenters from today as well. So thank you very much again, and we look forward to seeing you in the final session of our Passivhaus workshop. Enjoy, thank you.